Okay, so we're now recording. Welcome to the AutoGIS lesson related to OpenStreetMap data and network analysis 2021. My name is Vuokko Heikinheimo. I've been teaching this course together with Henrikki and Dave in the past years, and this year Howard has been excellently hosting the course, and I'm here visiting kind of just out of enthusiasm towards the topic, and nice to revisit the lesson here in Zoom. So hello to also those following the lesson then online afterwards. So let's get going. The numbers are a bit here and there, but you can find the materials under lesson 6. There's a short overview, but we'll skip straight to this OpenStreetMap data lesson. And before we start in practice, those following now in live time, you can launch your CSC notebooks. If you have an instance that you started like more than 2 hours ago, maybe destroy it and relaunch it. Otherwise, you should have the lesson 6 notebooks as usual under AutoGIS notebooks, lesson 6. So we have 2 notebooks for today, and we start with the 00 OSM data. So as a second warm-up exercise, I would want those who are now online, maybe you use these checkmark things, so put a green checkmark if that works, and if you have the CSC notebooks ready, so I know I can proceed in a bit. Great, so some check marks start popping up. Maybe Howard could monitor, and if there's some issues, Howard can help. For example, if you can't see the notebooks in there. Still, for those not within the Finnish university system, you can find the notebooks from GitHub or launch them in Binder. I think these should work as expected. All right, so quick introduction to the topic, and then we'll get on hands-on with retrieving and analyzing the data. But just to get everybody on the same page, I assume many of you are familiar with OpenStreetMap, but it's, to put it short, kind of the Wikipedia of maps, this open source global database that anybody can contribute to. So if you don't see your building or the street you're living in on the map, you can go and edit it. So it's this crowdsourced data set that is of quite high quality, especially in urban regions across the globe. And there's some statistics and information about that. Maybe more useful is to have a little look at the data on the browser. So openstreetmap.org, you'll see some representation. You can zoom in and out, and as you can see, the map is rendered in a bit different way. So I think in the map visualization class, lesson number 5, you use some of these OpenStreetMap tiles as background maps already. And some of you might have even contributed to producing this map. As you can see, I'm logged in here. And if I would zoom in, this is now Helsinki, and I will zoom into Kumpula, where I haven't been. I think Howard is now in Kumpula, so you can see how detailed the map is. There's different ways this underlying data can be rendered, so how the map looks like here. But in the kind of background, if you go to the editing mode, so you can then see the actual data in there. So again, this is now Kumpula campus. It loads a bit slowly, but there we go. So we have, for example, is that now? That's not Unisport. I think this is Unisport. Whoop. So that's the sports center at the campus. So it's a polygon feature. It has some attributes here. So basic GIS data elements, it has a name, And then there are these additional tags. So those of you who are familiar with OpenStreetMap, these tags are very important to understand. And then there's this whole OpenStreetMap wiki describing the meaning of these various tags. So then if we have another look, there's, for example, this road, which is a linear feature, so line feature. And again, it has various attributes. And with these road networks, this, for example, the highway tag, so the attribute is very important if we then want to do network analysis. Can we drive with a car on this road? Will be coded in these attributes here. And then the third type of vector GIS data, let's zoom in a bit more. There's, for example, the UniCafe, so the canteen at the Physicum campus represented as a point feature. So here you can see even individual trees have been mapped here. You can map entrances, so super detailed data. And all of this we can export or download for our own GIS analysis. So you can see here there's this export button. So you could even download data just like that. But as you can see, so here you can't export like massive amounts of data. So then the documentation recommends you to look at optional ways of accessing the data, such as the Overpass API that we will be using today via Python. Then there are separate kind of repositories for getting these data dumps or data extracts for even for the whole world or for the whole of Finland or some continent. Okay, so that's a bit of a technical introduction to the data we will be handling. So I recommend you to go to OpenStreetMap, maybe zoom into your local area, see if your house is mapped, is your neighborhood mapped, is the local, your favorite restaurant there. You can add it there and become an OpenStreetMap contributor, which is a nice thing. If there are some gaps in the data, you can yourself make the data better. All right. Okay. So that's it with the intro, and let's get down to Python business. So we will be using, there's a couple of main tools or Python packages that we're using. The first is OSMnx, so OSM or OpenStreetMap, which can be used to retrieve data from OpenStreetMap via the Overpass API. And then we can do further analysis based on this data. And then in the second part of the lesson, we will use NetworkX, which works nicely with OSMnx, so we can then construct these routable networks from the street network data in OpenStreetMap. And the main developer behind OSMnx is Geoff Boeing. So I recommend that you have a look at his personal website. There's been many updates since this paper published related to the tool. And in the in our course overview, it's rather old, but these things don't get old. So there should be, or at least Howard will update, hopefully the old link. So there is a YouTube video where Henrik Tenkonen interviews Geoff related to the tools he developed. So the tools are mainly for analyzing the urban structure, calculating metrics related to the urban structure, calculating accessibility indices and these sorts of things. So if you haven't yet decided your final assignment task and are interested in these topics, so then you can do a bit further reading on his work. Excellent. Great. So I hope now the check marks already disappeared, but I assume if nobody complains that we can proceed with the lesson. So as always, we start by importing the tools that we will be using. So at this stage, OSMnx, and it's quite customary to import it as OX, so it's shorter to write. And then actually here, we're just importing also PyPlot that you've been using a lot already since GeoPython as PLT as always. So we'll do some visualizations based on the data. So if you run those and they go through, that shows that your Python environment has these installed. Maybe a disclaimer that I just checked the OSMnx version that we have in this computing environment is not the very latest, but it's quite up to date in terms of the latest updates in the OSMnx package. There might be some features that are a bit outdated, but I think we'll be fine at least this year. I did a lot of updates last year based on the updates in the package, but next year, I don't know if it's then Howard or who might be then doing more refactoring to this lesson. Cool. All right, so we have the tools. So let's come up with a case example of retrieving OpenStreetMap data. And let's continue in Helsinki area that most of us know. So we'll be fetching some data from Kamppi during this lesson to fetch the data and do a little simple shortest path analysis. And when retrieving data with OSMnx, we're actually using the nominatim geocoder that you already used back in lesson 2 or something. So it's good to check. Let's still go to this website. I'll just show you. So if I search for Kamppi, just like that, what does it give me? So if you have problems downloading the data, you can check from here that the place you're trying to fetch data from is actually a geocodable region in OpenStreetMap. You might want to specify Helsinki, Finland to get the correct if there's similar place names in different places. But this will be our area of interest as defined in OpenStreetMap as the boundaries of Kamppi area in the central Helsinki. Cool. How can I go back here? So finally, some lines of Python code. So let's define a variable place name and assign a character string. So these hyphens and give Kamppi Helsinki Finland as the value. You can run that. So Shift Enter runs the particular cell. And if there's no errors, everything should be fine. And then the important thing, so how do we then pass this place name to OSMnx in order to get some data from using the Overpass API from the OpenStreetMap database? So let's have a look at the documentation. I'm now jumping back and forth, so I hope that's easy to follow. So this is now the documentation of OSMnx and all the reference for all the modules and functions within. And actually here, we are jumping straight into downloading the street network from this Kamppi region. So there's various access methods for getting different types of data. And here we start with the street network that is central to our task later on today. So there's this graph from place method, and we can see that there's some crucial parameters. So we need a query string, so some text. We have this Kamppi Helsinki Finland. So the query to geocode, okay, we have that. And then we could specify additional parameters, but we'll get back to those a bit later. But keep in mind this documentation, I don't remember these by heart. You always have to go to see the actual specifics of these parameters and then for example, the type requirements. Okay, so how can we do this? We have this OSMnx.graph.graph from place. Basically, we can call it like this. Wait. So let's create a variable graph that will be our street network. Then OSMnx module.graph from place. And then we needed this query string, which is stored in this place name variable. And you can run that. Let's hope there's not too many timeout errors or something while we are all doing this at the same time. I'll type in the next commands here while waiting. Okay, I at least got mine. Maybe if you don't in, let's say, 30 seconds or so after running your query, if you don't get the graph, put the red X and maybe Howard can stop me. Otherwise, I'll just continue. It takes a while because we're downloading all the streets without filtering out anything. So it is a bit slow, but still we have quite a lot of data that comes out from there. Okay, so I got my result from this graph from place. Based on this place name query, it got geocoded, it got this Kamppi area, and within that area, we should have some street network data. Okay, so here we have a new data type. I bet you haven't seen this yet during the lesson. So there's this network X class multi-graph. So it's a certain type of graph object. You can read the specifics from the network X documentation, and we'll dive a bit deeper into that later on. OSMnx has these inbuilt functions for plotting these graphs. I already typed it in. I'll just quickly show how I knew what to type in. So this plot graph returns a figure object and a subplot object. So that's why we need to write it like this, that we store the figure and then the one subplot that will then plot this graph. And it should look something like this. So there's a lot of data. It looks a bit like OpenStreetMap in the editing mode. There's all the nodes, so all the junctions or wherever anybody has kind of clicked on the line when editing it. Those of you who know the region, there's Ruttopuisto here. Tennispalatsi would be somewhere in here. Baana would go there, a bit outside the area. Boulevardin here and so on. Okay. Next, we have this weird graph object we're not too familiar with yet, but you should be familiar with GeoDataFrames from GeoPandas, and those are useful if you want to store the data to a file or if you want to use your GeoPandas and Pandas skills to modify the data or visualize the data. So just to show, I left these code cells in here to speed it up a bit, but there is this OSMnx graph to GeoDataFrames method that takes in the graph and returns the nodes. So these little nodes in here and the edges, so the basic elements of a graph as separate GeoDataFrames. And then we can check using these basic Pandas tricks what the actual data and its attributes look like. All right, so you can see the nodes. So the nodes are the little dots or the points that connect the actual edges or the road segments. There's XY location in decimal degrees, some kind of ID that's also in the index. We have some highway tag, perhaps not always. So this is then a crossing. That's some reference information, and then the shapely object in the geometry column. So quite regular GeoDataFrame. Then you have the edges, so there's a bit more information. Is it so ID? Is it one way? Yes or no? How many lanes? What's the name of the street? The highway class, speed limit, length, so on and so forth. So there's a lot of information that can be linked to these road segments in OpenStreetMap that can be then used as additional information in routing analysis. All right, great. Okay, somebody's asking, can you recap briefly the code? Just got my data fetched true. So I can go up, and you can always go to the website. Then you can see briefly, you got your data fetched true. So if you have the graph, you're ready to go. And basically what you need to do, you can even skip this plotting step. You can see it here. Next step is that you can basically run this graph to GDFS function. So you have these nodes and edges in memory, and then you're good to proceed. All right. If there's something else I can clarify, please just ask. Okay, and here we were just checking the data, so these are not necessary for the next steps. All right, so first step is done. We have defined our area of interest because we don't want the whole world of data here. We have Kamppi Helsinki, and from there we have the street networks. But then what we kind of skipped a step, so we didn't really get this. We have this, where was it? This like the actual boundaries of our area of interest. You might need those for visualization or some other overlay analysis purposes. So we can also fetch those from OpenStreetMap. So there is this function called geocode to GDF. Let's again read the documentation. So what this does is that it retrieves places by name or ID from the Nominatim API, as mentioned, straight into a GeoDataFrame. And there again, we at least need to specify the query, and then there's some additional parameters. But we are good to go with the query. And let's synchronize the variable names. So I will call it area. So a new variable equals OX dot. You can copy paste the name from there or type in geocode to GDF. And pay attention to these kind of rather informative function names. If you write your own functions, try to make the function names as informative as possible. And there we want to put the query. So our query was this, what was it called? Place name. Place name was the name of the string, character string containing the place we want to geocode. I notice I'm moving slower than I thought, but that's fine. We have quite a lot of time. Okay, so what we have there is a GeoDataFrame. We can check the contents. Okay, so there's one row of data, there's a polygon, there's a name, and then there's a bounding box. So this kind of like minimum and maximum X and Y coordinates. And then using your GeoPandas skills, you can do area.plot, just a very simple plotting of the data, and you could then add a base map or whatever additional data in there. So there we have the actual area that we geocoded. That is our area of interest in this case. It could be, of course, the whole of Helsinki, some city, but here we keep it small in order to not to get into trouble with processing time. All good? Great. So then what else can we get from OpenStreetMap? You remember I showed that there were these building polygons, so footprints. So there is then this family of functions called that can fetch these geometries from OpenStreetMap. So we will use geometries from place function to fetch the building polygons. And what does that do? So it will, as an output, so it will return a GeoDataFrame, GeoPandas GeoDataFrame and then within boundaries of geocodable places, so we have the query and OSM entities. So that's quite a broad category. So we could fetch, let's say, forests or whatever else that has some kind of a footprint. But here we want to then specify using those tags that I showed at the beginning that we want to fetch specific tags from OpenStreetMap, for example, buildings. Okay, so OpenStreetMap tags is a whole long list of attributes available. I don't know if this now opens, but for example, buildings, let's say I think there's some kind of a list. So there's a long list of different types of buildings that can be present in OpenStreetMap, and we just want to get all of them. So in that case, the tag would be building equals yes, and how we need to pass it to OSMnx is to use a dictionary. So we could have several tag key value pairs. So building is the key and value yes, or value whatever apartments would be then a more specific tag. But here we will put as the key buildings, and then as the value in the dictionary, we will just put true. So this syntax will get all the items in OpenStreetMap that have key building, whatever is then the more specific value. And this is a dictionary object that I hope you have covered earlier in the course, maybe somehow. Yes. Okay. So once we have defined the tags, we can again go back to this geometries from place. So we have the query, which is our area kind of boundaries of geocodable places. So Kamppi, we have the tags, and then the rest of the parameters we can ignore at this point. So you can read more examples of how to specify the tags from the documentation. All right, so again, OX, geometries from place. We had the query, which is place, name, and then tags, which is a dictionary. So that should be now correct. This might take, again, a while. I need to run that as well. And this one, so I'll stop here for a second. And once this goes through, I should have a GeoDataFrame containing buildings from the Kamppi area. I'm hopeful that this will run quite soon. Let's give it a couple of moments. At least I hope everybody had the time to type it in. In the interest of time, I'll prepare the next step, and let's see if we get into troubles with downloading the data. Similar, you can also just run it, and then let's see in a bit if we actually get the data. So same thing, we have now fetched lines. So the street network, we have fetched polygons, or soon we'll have fetched polygons, so the buildings, and then we can also fetch points of interest, such as restaurants, which would be useful for, let's say, accessibility analysis or service accessibility. So in OpenStreetMap, there is this tag category called amenities. I'll show that quickly. Oh, well, that was a poor link. But anyway, for example, a restaurant is an amenity, one type of amenity. So there we want to specify both the key and the value. So the key value pair amenity equals restaurant in order to get only restaurants and not every bus stop and parking lot. And so there's a bunch of amenities in OpenStreetMap. So in this case, we want to have a more specific tag list, amenity equals restaurant. Okay, and at least now I got my buildings, but I think, do I have a typo there? I'm also very good at typing typos when I am speaking. Building, yes. So singular, tag building equals true. So let's see. I hope we lost some time there, but it should be a bit faster, perhaps. So building equals true. Should stick to the notes and not think I remember how things are typed in. So it's very, very specific. It needs to be the very exact key. So now it went true, at least here. So I got 437 buildings. Again, now if you have this correct key value pair tag and you run this, if you don't get the result in a couple of moments, put the red X and we can then think about it. But I think it will be fine. And again, now we have a different set of features. So buildings, there's plenty of attributes. Not everything is available for each polygon. And then there's even a attribute for a Lippa kioski. It's probably Boolean, true or no, if it's a takeaway restaurant. So all sorts of columns. So if you print out the columns, you can see that there's 103 attributes for the building. So often then you might want to drop some of those out if, for example, printing those data into a file. Excellent. So now we get to proceed with the amenities. So amenity restaurant, that should be correct. I think this was readily typed in. So again, place name and tags. So we just repeat the same process with different parameters. And soon we should get some restaurants from there. And again, we can check the columns. And then here I have suggested a list of columns to select from the broad selection of columns that we will soon get from there. And then I'll type this in already. Let's say restaurants. Yep. So you could have this list inside here or do it like this. It's maybe more easy to follow if you have it. The selection printed out separately and then that one. So let's see what we got. I got 166 restaurants from this rather small Kamppi area. So it's a very central location with lots of services and options for food. And again, there's quite a lot of columns, not as many as with the buildings, but still. And then we can print these selected columns so that we can actually see the data. So we have names of the restaurants, some even have opening hours. So that's something you could go and update to OpenStreetMap if you want. Address, different elements of address, and so on and so forth. All right, all good so far. If somebody is in trouble or confused, now is a good time to ask. Okay, great. Thanks for the correct link. Maybe Howard can update it to the web pages, or I think there was another broken link somewhere. So, or you all can go and suggest and edit to the pages. So we're closing to the end of this short introduction on how to fetch points, lines, and polygons from OpenStreetMap. But let's continue exploring the data a bit to see what we actually got as a kind of GIS data. So there's this one line that creates us this figure and subplot object so that we get a bit bigger figure than with the default settings. So then we can plot these different layers to that specific subplot. Let's see what happens in here. Now I need to scroll up and down a bit. So of course, as we will be plotting different data, we might want to change, put some parameters to change the colors. So this all should be familiar to you, but a bit of recap. If we have multiple layers, a good practice is to create the figure object and start populating it with the layers in the order of which you want to plot them into the map. So this will be the bottommost layer, kind of the background or footprint. Then we could plot the edges that we have now as GeoDataFrames, again to the same object. And with lines, we control the color with edge color equals, you can try different parameters, but I'm now doing what is in the lesson notes. And you can also control the line with, I don't remember what's the defaults, but that's maybe a bit more narrow. We can plot the buildings, again, to the same subplot. And then the restaurants. Oops. Ding. Okay, that's the basic syntax. And then of course you can start. I need to now scroll. I'll just keep it here with the code visible for you guys. You can add this transparency using this alpha. Maybe that's more useful in the buildings. You could add a base map using contextually, as you learned before, all these things if you want to print out the map. But this is a useful thing to integrate in your data analysis notebooks, even though you're not making a fancy, nice map. The visual exploration that you actually got the data from the same area, that there's not like major gaps in the data. So this is mainly for just to do a visual check on what we got from the interface. All right, I'll leave it there for a second. All right. Do we have contextually in this notebook now? Maybe I'll show contextually after the break. You could of course then confirm the kind of spatial context by just plotting the base map there, but in the interest of time, maybe I won't add it now. But here you can see the clusters of restaurants in Kamppi, at least how they have been mapped into OpenStreetMap here. And now you could then of course save these data to file or whatever else. All right, I'll proceed now. If you missed some of these, there's more parameters on the web page for example, maybe I show this marker size is quite useful for the restaurants. So you can change the size of the dots and all these things. It's always difficult to remember what are these actual parameter values here. So Google is your best friend, or the web pages of the course. Okay, so that was basically it. We learned how to fetch the graph as a root. It's a routable network, and we will work forwards with it after the break. We learned how to fetch the area of interest as a polygon. We learned how to fetch the buildings and how to put the correct tags and maybe how to check the tags from OpenStreetMap if you're hesitant on what to download. Also the restaurants, and then for the amenities, there's a bunch you could download, whatever, public toilets, the trees, movie theaters, all these sorts of points of interests and attractions that might be useful, for example, in analyzing service accessibility or mixed land use and these sorts of things. All right, so there is still an additional section. All of the following code is already typed in, so I won't go this through more detailed, but this might give you ideas, for example, for the final exercise, and there's a bit more advanced or more detailed parameters used here. So how to fetch urban parks similarly to the other features. So with the parks, OpenStreetMap tagging practices are not so straightforward. So there's, for example, this leisure key. So you might have leisure equals park. Then there's land use tags. So you might have this like more just grass somewhere, which is also urban green space. Then you might have playgrounds, some kindergarten backyards. So if you want to fetch green spaces, you need to do a bit more investigation on the tagging of these features in order to fetch them all. But here there's an example of how to then specify multiple tags. So we get from the key leisure category, we get parks. And then in the dictionary, we just add another key value pair, land use equals grass. We can save that, repeat the same thing. We can ignore these deprecation warnings. They are related to the Conda environment that runs here in the background. So here I got 55 park polygons. Check quickly how it looks like. So for example, Simon Puistikko, probably Ruttopuisto is there, Vanha Kirkkopuisto, all these. Quick visual check, and then finally you can plot everything on top of each other. All right. So that's it for the first part of the lesson. I think it's relatively simple and straightforward. Of course, if you want to then repeat this over multiple areas or fetch data from larger area or do some quality control on the data, then you need to expand from here. But this is a good start. We won't do this now, but if you want to check your understanding on your own time, you can then retrieve similar data from another area of interest. So extract the area, extract the street network, extract some amenities, cafes, restaurants, bars. And indeed, we can also download these only networks for cars and such, but we'll talk about that soon. So here's some code cells if you want to just test your understanding, recap. And then for the advanced users, of course, here we were still in a quite restricted area in terms of the extent. So if we would be doing, let's say, analysis across the whole of Finland or even the whole of Helsinki, it might be meaningful to download these data dumps, for example, from this GeoFabric service, and then take a different approach of fetching the data into OpenStreetMap. So there's this PBF file format that you can, for example, download whole world OpenStreetMap data, and then from that data dump, extract the streets. But there the downside is that, of course, then you need to download the data in order to get the latest data. Here we get the latest data straight from the API. Anyway, but if you want to dig deeper, there's this tool developed by Henrikki for working with these PBF files in Python. I have used that now, this Automating. It's quite handy. And you can, for example, then generate these like street networks, routable street networks over large areas for further analysis. So do have a look at this even for the final exercise if you want to do a bit more advanced analysis. Cool. So I'm done here now. I think the schedule is similar to last year. I was hoping to be a bit faster this year, but that's how it goes when there's some typos and stuff. So I'm happy to take questions, and then I would suggest that we take a little break, continuing 1/4 past.